Einstein A B coefficients. Einstein coefficients are mathematical quantities which are a measure of the probability of absorption or emission of light by an atom or molecule. The Einstein A coefficients are related to the rate of spontaneous emission of light, and the Einstein B coefficients are related to the absorption and stimulated emission of light. Einstein quantum theory of radiations. Basic concepts. For Einstein quantum theory of radiation, we find Einstein A B constants. The basic concept is, first of all, we find absorptions and spontaneous emission, then stimulated emission. Okay. So, what is the mean by absorptions? The energy level E1, the energy level E2. E1 mean for ground states energy level, E2 means for existed energy levels. Now, the ground states atom, this number of ground states atom, that means N1. Okay, so the ground state atom absorbing incident photon radius, that is value for rho b. Okay, then rising exit. So this process is known as for absorptions. Okay, so rate of absorption R12 is proportional to dependent for number of atoms in ground state and incident photon radiation. So N1 and rho v. Okay, then R12 equal to, the proportion is equal to constant, that is value for B12 N1 rho v. Okay, here B12 is mean by is a probability of absorption constant. Okay, that is equation number 1. So next is the stimulated emission. Okay, then existed one atom. Okay, that is value for N2. Okay, returns to ground states, releasing single photon. Okay, released to single photon. So this process is known as the spontaneous emission reaction. This spontaneous emission reaction is especially for independent reaction because it's existing atom returns to ground states without triggering. Okay, so rate of spontaneous emission R12. Okay, R21. Okay, R21 is proportional to what answer? Is depend only for number of atoms in existed levels. Okay, so R21, okay, is the SP. SP means spontaneous emission. Its value is for equal to A21 N2. Okay, A21 N2 this is equation number 2. Okay, here A21 mean 5 is a probability of absorption the spontaneous emission constant values. Okay, so next we go to for another one case, stimulated emission reaction. When existed one atom absorbing incident photon radiation, okay, and returns to ground states, it is releasing for 2 photons, okay, this process is known as for stimulated emission reaction. Then after stimulated emissions, then these 2 incident photon energies absorbing 2 existed atoms, then returns to ground states releasing 4 photons. Again, the 4 photon absorbing 4 existed atom returns to ground states releasing 8 photon. The 8, 16, then 16 to 32, 32 for 64. That is increasing the population inversion. We find the stage of laser. Okay, so starting stage for chromatic sources, then finally for is a monochromatic source, that means for laser light amplification. Okay, understand? Now the rate of stimulated emission value R21 is T for stimulated emission is proportional to dependent for number of atoms in existed level and incident photon radiation. Okay, so R21 is T equal to B21 N2 OB. Then equation number 3. Okay, now at thermal equilibrium, so rate of absorption value is equal to rate of emissions value equal. Okay, rate of absorptions value equal to rate of emissions value equal. So, okay, so rate of emission, the absorption value equation to 1 is equal to 2 plus 3. Okay, then equation number 1 B12 N2 1 rho v equal to A21 N2 plus B21 N2 rho v. Okay. Here the right answers are rho v, then shift to left side. So B12 N1 rho v minus B21 N2 rho v equal to A21 N2. So here this is the N2. Okay, so N3 is both sides divided by N2. Both sides divided by N2. B12 N1 by N2 rho v minus B21. Here N2 by N2 divided by is equal to 1. So that's value for rho v values. Then equal to A21. Okay. So in this case the common factors for rho v is a common factor in the photon radiation. So rho v is equal to B12 N1 by N2 minus B21 equal to what answer? A21 values. So okay, A21 values. So now this is a common factors. Okay. Okay, so now this value for rho v. So rho v is equal to A21 divided by what answer? B12 N1 by N2 minus B21. Did you understand? So now this equation number 4. Okay, equation number 4. Now we find what is the N1, N2 values. We already know that by Boltzmann's law explained number of means for number of ground state electron, down state number of electrons, existing number of electrons value already calculated from Boltzmann's law. So apply for Boltzmann's law. N1 is equal to N t power E1. It's a number of N1 is equal to what a number of ground states energy level. So E1 divided by kBt. N2 is equal to N t power minus E2 divided by kBts. So you understand. So just to form N1 by N2. So N1 by N2's value. So N0 cancellations. So N0 e power minus E1 divided by kBt divided by N0 e power minus E2 divided by kBts. So N0 cancellation at the same time 1 by e power minus x. So if we numerical, that is what is plus x value. Then finally form the answer is e power E2 minus E1 divided by kBts. Understand? Now is E2 minus E1. What answer? E2 minus E1. Higher energy states level to lower energy states level. Okay, the atom exit state level to lower energy states, then releasing photon. That is value for h mu's value. So E2 minus E1 is equal to h mu. Understand? So just replace e to e power h mu divided by kBt's values. Okay, so N1 by N2 equal to e power h mu divided by kBt. Understand? Now this is equation number 5. So equation number 5 substitute equation number 4. So equation 5 substituting in equation 4. So rho v equal to A21 divided by B12 e power h mu divided by kBt is minus 1. Okay, minus 1 values. Now, sorry, going to B21, B12. Okay, so now both is divide by B21 values. So divide B21. So rho v equal to A21 divided by B21 divided by B12 divided by B21 e power h mu divided by kBt minus 1. Okay, that is answer, buddy. Then this value is equal to number 6. Now the incident photon radiations, these values compare the Planck radiations formula from Planck radiations law. So the Planck radiations law's value already know that. Planck's law, okay, and compare, okay, equation 6, okay. So Planck radiations law value already know that is rho v is equal to 8 pi h mu square divided by c square 1 divided by e power h mu divided by kBT minus 1, okay. Like this for Planck radiations formula, Planck radiations values or incident photon radiation. Just this incident photon radiation, compare the Planck radiation formula. Just to compare the equation for 6 and 7. There is like this equation 7. Compare equation 6 and 7. Okay. Then B12 equal to B21, because just to compare A21 divided by B21 is equal to this values 8 by h mu square divided by c square. Otherwise 1 divided by e per h mu divided by kBT minus 1, 1 divided by h mu divided by kBT minus 1 is only for possibilities. Otherwise these values is equal to 1, because is a B12 is a B21 is equal to B is only possibilities. Okay, that's why my final answer is A21 divided by B21. Okay, equal to what answer? This value is equal to this one. So 8 by h mu square divided by c square's value. Okay, like this is Einstein A B coefficients value. Like this Einstein A B coefficients value, A21 is meant by the spontaneous emission value, spontaneous emission probability constant. The B2 means for stimulated emission probability constant, stimulated emission absorption probability constant values. Okay, so these values proportional to mu squares. Okay, because otherwise by 8 by h divided by c squares also constant. So A21 divided by B21 is proportional to mu squares value. Like this is the Einstein A B coefficients. Thank you.